Hi, in this video I will be showing you problem number 15 of chapter 15 section 3. Use a double integral to find the area of the region. The region is one loop of the rows or equal to cosine of 3 theta. So we are asked to use double integral to find the area of one loop of the rows or equal to cosine of 3 theta. So how do we change? First, in order to do double integral, and we are going to use polar coordinates here in this problem. How do you change from rectangular coordinates to polar coordinates in a double integral? Why would you want to make the change? We may want to change from rectangular to polar coordinates in a double integral if the region D of integration is more easily described in polar coordinates. And also, the region D is all those are theta, and theta lies between alpha and beta, and R lies between the curve h1 of theta to h2 of theta. To evaluate double integral over D, f of xy dA, in polar coordinates, we get its integral, theta running from alpha to beta, and R running from h1 of theta to h2 of theta, and then x and y changing to r cosine theta and r sine theta. So the integrand becomes f of r cosine theta, r sine theta, then the dA would become r dr d theta. Okay, this is a formula we are going to be using in this problem. So we need to find the area of one loop of the rows are equal to cosine of 3 theta. To graph the polar curve, set r cosine of 3 theta equal to 0. So we are seeing where it crosses the r axis. So it will be 3 theta equal to 0. 3 theta equal to odd multiple of pi by 2. If r equal to 0, cosine 3 theta equal to 0, and 3 theta would be odd multiple of pi by 2, or theta is odd multiple of pi by 6. So we'll take the first one because we are asked to find only one loop. So we can consider the polar graph of this rows r equal to cosine 3 theta. You have done these graphs in your calculus 2 class, just a revisit of this topic. So whenever you do polar graph, it's ideal to do the Cartesian graph first and then the polar graph. So that's what we are going to be doing here. So Cartesian graph of r equal to cosine of 3 theta. R equal to cosine of 3 theta has the period 2 pi over 3. So we graph the Cartesian graph as follows. So the theta axis, we need up to 2 pi by 3, and we will take little more. So it is, the period is 2 pi by 3, will go up to pi. Then we'll replicate the cosine graph here. So it's like a tongue-shaped graph. It goes like this, up to pi we consider. It goes beyond, but we consider only up to pi here. So it is, we will consider the branches like this: one segment, segment 2, segment 3, segment 4, segment 5, segment 6. And we'll translate that into polar graph. Segment 1 tells us that the value of cosine decreases from 1 to 0 as theta varies from 0 through pi by 6. Then 2, the branch 2 or the segment 2 tells us as theta increases from pi by 6 to pi by 3, r goes in the opposite way from 0 to -1. So these are some of the ideas that we are going to use in graphing the polar graph of the function. So if we graph polar graph, So we have to see the branch between negative pi by 6 and pi by 6, and we get the graph. So this part corresponds to 1, and then we can actually mark 1, 2, 3, 4, and then we are going to translate the Cartesian graph into polar graph. So 1 is in the first quadrant, and 2 is in the third quadrant, 3 is in the third quadrant as well, and then 4 is in the second quadrant, 5 is in the second quadrant, and 6 is in the fourth quadrant. So we can complete the polar graph like this. Then we are finding area of one loop. So that's a part it's been shaded here. So let's consider the area now using the polar coordinates that we just discussed. The region, the polar region over which the curve is defined is set of all r comma theta, and r runs from negative pi by 6 to pi by 6. So that's what the graph shows. And then r runs from 0 through cosine of 3 theta. That is the equation of the graph. So you can write this as r equal to cosine of 3 theta. And we are going to find out the area using double integral. Area of one loop is double integral over d dA, which is integral theta from negative pi by 6 to pi by 6, and for r it is 0 through cosine of 3 theta r dr d theta. This dA changes to r dr d theta. We'll call it equation A. So we'll integrate the inner integral first and then outer integral. Area is integral negative pi by 6 to pi by 6. If we integrate the inside one, it is half of r square between r equal to 0 to cosine of 3 theta d theta. So which is half of cosine square of 3 theta d theta. Then that is an even function. So negative pi by 6 to pi by 6 for an even function can be written as twice 0 to pi by 6. We use that. So half times 2 times 0 through pi by 6. Then for this one we use the double angle formula, 1 plus cosine of 2 times 3 theta, which is 6 theta divided by 2, which we get that to be 1/2. These two cancel out, so 1/2 theta plus sine of 6 theta over 6 between the limit 0 and pi by 6. So plugging into the upper limit and then subtracting at the lower limit everything becomes 0. So we get half of pi by 6, which is equal to pi by 12. Hope this video helps.